Hi guys, so today we're going to be talking about solving systems of equations. We're going to start by talking about solving systems of equations by graphing. Okay? So recall that a solution to an equation can be thought of in two ways. It can be thought of algebraically, where when I plug that solution in, that point in, it makes the equation true. Okay? We can also think about it graphically, where that point is on the graph of that line. Okay? So understanding systems of equations, first of all, a system of linear equations is when you have two or more linear equations. Okay? So a system is when you have two or more of them. The solution to a system of equations can be thought of also in two ways. Algebraically, when you plug that point in, it makes all of the equations true at the same time. Okay? And you can think about it graphically, where it is on both graphs at the same time. So we're going to see that here with 3, 4. We're going to verify that 3, 4 is a solution to the system. Okay? We're going to do it algebraically by plugging it in. So I'm going to do y equals x plus 1 in green, and I'm going to do y equals 2x minus 2 in pink. Okay? So what I'm going to do is I'm going to take 3, 4, its x and y value, and plug it in. Okay? So I'm going to plug in 3 for x, 4 for y. So 4 equals 3 plus 1. And when we're testing or checking our points, we're just doing order of operations. We're not moving anything to another side. So 3 plus 1 is 4. Does 4 equal 4? Yes, it does. So algebraically, 3, 4 is a solution to this first equation. Okay. Now I'm going to check it for the next one. So plugging it in again. So 2 times 3 is 6. 6 minus 2 is 4. Does 4 equal 4? Yes, it does. So algebraically, it is a solution to the system because when I plug it in, it makes both of the equations true. Okay? What does it look like graphically? Okay, so I'm going to graph y equals x plus 1. So y-intercept is at 1. Slope is 1, 2. So I go up 1, right 1. And the reason why I'm going to do it all the way is because that way my graph is as accurate as possible. Because sometimes when you're further away from your two main points, it ends up being a little bit off center. Okay. So here is y equals x plus 1. Okay. Then I'm going to graph y equals 2x minus 2. So y-intercept at negative 2. Slope is up 2, right 1. Okay. Then I'm going to connect. And here we can see that the lines intersect at one point. They intersect right here at 3, 4. And that is why 3, 4 is a solution. So when we're solving for systems, there are 3 different cases. Okay? The first case is kind of like what we saw here. It has one solution, which means that the graphs of the lines touch at one place. And we know that we will have one solution when the slopes are different. We will have no solution when we have parallel lines, because we know that parallel lines do not intersect. And what we know about parallel lines is that the slopes are the same, but the y-intercepts are different. And so as a result, we have parallel lines, and because parallel lines don't touch, there will be no solution. We end up having infinite or infinitely many solutions when we end up with the exact same line. And in that case, the slopes are the same, and the y-intercepts are the same. And we end up with the exact same line. And so it touches everywhere on that line. And that is why there is infinite or infinitely many solutions. Okay. So let's practice a little bit more and see it in action. Okay, so each one of these, I'm going to do one of them in green. And I'm going to do one of them in pink. Okay, So starting with this first one, 2x plus y equals 4. For this one, if you want, you can graph it using intercepts, or you can change it into slope-intercept form. And by doing that, you solve for y. So I'm going to subtract 2x on both sides. So then I end up with y equals negative 2x plus 4. Okay. So y-intercept at 4, and then my slope is negative 2, so I'm going to go down to right 1. And then I'm going to connect my dots. Again, the reason why I'm doing it all the way across like this is so that way it stays as accurate as possible. Okay. Then the next one here, I have 2y equals 2x plus 2. So I'm going to change it into slope-intercept form by getting y by itself. I end up with y equals x plus 1. Okay. My slope is also 1, so up 1, right 1, up 1, right 1, up 1, right 1. Okay. You probably already saw where it intersected. Okay. Then I'm going to connect the dots. Okay. And where it intersects, where it touches, is my solution. Okay, so it touches right here, and this point is 1, 2. And so that is my solution to the system. If I wanted to check my work, I could take this x and y value and plug it in, and I would see that it is true. Okay? So let's do the next one here. 2x minus y equals negative 1. So I'm going to change it into slope-intercept form again by solving for y. Get rid of this negative 1 in front. Y equals 2x plus 1. Then I'm going to graph this starting with my y-intercept at 1. Then I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay. And then connect the dots. Then I'm going to graph the next one. So this is negative 4x plus 2y equals negative 6. So I'm going to add 4x to both sides. So this will give me 2y equals 4x minus 6. I'm going to divide by 2 on both sides. So this gives me y equals 2x minus 3. Okay. So y-intercept at negative 3. And then my slope is 2, so up 2, right 1, 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 up 2, right 1. Now I'm going to connect. And as we see here, these lines don't touch, they're parallel. Okay, and again, I could verify that because they have the same slope. They both have a slope of 2, but their y-intercepts are different. And so as a result, these lines are parallel, they don't touch, and so there is no solution for the second one here. Okay. Now I'm going to try the third one here. So y equals negative 2x plus 3. So that one's already in slope-intercept form. So y-intercept at 3. And then slope is negative 2, so down to right 1, down to right 1, down to right 1, down to right 1, down to right 1. Okay. And then I'm going to graph it. Okay. And then I'm going to do the next one. So 6x plus 3y equals 9. So I'm going to change it into slope-intercept form. I'm going to subtract 6x on both sides. That gives me 3y equals negative 6x plus 9. I'm going to divide by 3 on both sides. This gives me y equals negative 2x plus 3. What you will recognize is it's the exact same thing as what I had before. So if I were to graph it, I would get the exact same line too. Okay. And as a result, they touch in every single point on this line. And so as a result, I have infinitely many solutions. And so here you see the 3 different cases, right? one solution for when our slopes are different. It will touch in one place. No solution when we have parallel lines. The slopes are the same, but the y-intercepts are different. And then infinitely many solutions when we have the exact same line where the slope is the same and the y-intercept is the same. That's it for today. Have a great rest of the day. Bye, guys.